Now we continue with re-engineering, which we could retitle as modernization engineering. So first some terminology: refactoring, restructuring, re-engineering. These are not the same things, except that the refactoring and restructuring basically are. So refactoring is from the object-oriented programming world, basically means the same as restructuring in the structured programming. So refactoring and restructuring is something that good programmers regularly do to improve source code maintainability, evolvability. So that's a maintenance activity. And should be part of any programming activity for large programs to keep it evolvable, maintainable, modifiable. However, re-engineering is a project of its own. It's not the day-to-day activity. I mean, it's a project that can last over several months. So it's basically the technical part of the software modernization effort. It's the engineering part of that. So what is re-engineering? Re-engineering is the examination, analysis, and restructuring of an existing software system to constitute it in a new form. So it has three basic steps. So reverse engineering, where you study the existing system, then the delta, the differences, what you want to do, how you want it to be different, and then the forward engineering is you implement the new system. So the goals here are to understand the existing software system and improve the existing software system by implementing it in a new form. So you get from a bad system to a good system. Typical objectives for re-engineering projects are to improve maintainability, migration to new technology, improve the quality of the system, different qualities of it. Could be user interface, could be performance, could be security, could be all of these. And then finally, to prepare for functional enhancement or actually do some functional enhancement along the way. Typically, you would want to address all of these goals and perhaps even more in a single re-engineering project to maximize the benefits what you get. Here we have a couple of important principles of re-engineering, and this is a quite important slide, so you might want to stop the video and study the slide in your own pace. In the center we have the pyramid, so let's start from here. We have different views to the software system. So if we think about the salary system now, the system that is used to pay people's salaries. On a conceptual level, we answer the question of why does the system exist. We are not talking even requirements here. So the question of why is, well, we need to be able to pay people their salary. There might be other conceptual reasons, but that's like one of the topmost. Now, the next level are the requirements. So those are the detailed requirements. System must be able to do this and that. And that's answering the what question. So what does the system exactly have to do? Then the design level is what and also partially how. So it sort of puts more details on the requirements on what it does, but also how it does it. And finally, the implementation level is just how. I mean, this is how it actually happens in the system. Okay, so now we have this pyramid view of the system. And going down pyramid, like I just told, we start from the top of what does this system do, and then we go downwards, is called refinement. And basically, we replace some aspects of the system with more detail. So if in a conceptual level we think, why does the system exist? And the answer is we must be able to pay their salaries. Okay, so if we do refinement, then we go into more details by introducing the detailed requirements of how the system actually functions. So we get more details in the requirements. Design would have even more details on, database connections, class architectures, front ends, back ends, whatnot. And then the implementation would contain all the details of what the system does. So going downstream, refinement. But since we are doing re-engineering, reverse engineering, in particular, we must also do the abstraction. So we must, in some case, replace the details with more abstract information. So we start the abstractation process from the bottom of how does the legacy system work. Then we reverse engineer some type of design, what and how. Then we might be able to identify key requirements. And finally, we would arrive to the conclusion that, why the abstraction process is final step. Well, we need to pay the salary, so we arrive at the top. So, principle of abstraction. The level of abstraction of the representation of a system can be gradually increased by successively replacing the details with abstract information. So, from details to abstract. And the refinement, the level of abstraction of the representation of the system is gradually decreased by successively replacing some aspects of the system with more details. So we get rid of the abstract information and we put in more details. Okay, and in re-engineering projects we have two steps. We have reverse engineering and forward engineering. And forward engineering is the engineering as usual. You do it like a waterfall model or like agile. You start from requirements, design, implementation, unit testing, system testing, operation. And you can do iteration and whatnot. But the other part of the reverse is the reverse engineering. So you start from the operation, you see how the system works in the operational environment. You see what it does, you see what's going on, what databases, what's happening. Then you perhaps do some testing, like backwards. You make the system run in a testing environment. Then you look into the implementation, do some unit testing, see how compile the system, see how it works. Then you reverse engineer the design, then you reverse engineer the requirements. So you arrive with the requirements after the reverse engineering process. So in more detail, reverse engineering, opposite of forward engineering, analyze the existing software system, you identify components, identify relationships between components, represent these components and relationships at the higher level of abstraction. So you move up in the abstraction pipeline. You identify requirements as the original ones might be lost. Examples would be decompilation, model diagram from source code. So in the extreme cases, you might even have lost the original source code. So then you would need a decompiler to get from assembly language to higher level representations in C. So you would have like assembly operations, and then you would be this decompiler would analyze this assembly language thing and produce something that looks like a C language. And then that would be easier already to analyze what is going on if the source code is lost. If design documents is lost, source code can be turned to models. So you take a bunch of models, a bunch of Java classes in this example and then it turns them into UML diagrams. So what follows next is a small demonstration of how reverse engineering works.